Hi guys, today we study about a stream in Java. What is a stream in Java? Streams are introduced in Java 8. Streams are powerful abstraction for processing sequence of element in a functional style. They enable you to process collection of data in a declarative pipeline-based way without writing boilerplate iteration code. Now we will see the key points. A stream do not store data themselves. Streams operate on a source like a list, set, or array. They support largely evaluated pipelines. Intermediate operations are evaluated only when a terminal operations run. So, what is intermediate operation and terminal operations? We will study about in next slide. Streams are immutable in the sense that they do not modify the source, instead they produce new result. Now we will see why do we use streams. To simplify complex data processing by using filter, map, reduce or collect, to write concise, readable functional style code, to enable easy parallel processing, to avoid side effects and make data transformation easier, to maintain and test. Now we will see the stream pipeline structure. Stream pipeline consists of a source like a collection, array, or an input output channel, and zero or more intermediate operations like map or filter, a terminal operation such as collect, count, for each, reduce. Intermediate operations are lazy. They build up the pipeline but do not execute until the terminal operation is called. Now we will know about stream operations. Basically, there are two types of this intermediate operation and terminal operations. But first we will know about intermediate operations. Here is the list. Map. It transform elements. Filter elements by condition. Flat map. Flatten nested structure. Sorted sort elements. Distinct remove duplicates. Limit stream size. Skip elements. These are lazy, meaning they do not process until our terminal operations is hit. Now we will know about what is terminal operations. It will return a result or a side effect. Terminal operations are collect. Basically, it gather elements into a collection or a summary or a list also. For each, it will iterate each element. Reduce, combine element into a single value. Count, it will count number of elements. Find first or find any to get an element, and this is for match predicates. Terminal operation triggered the pipeline execution. Now we will see an example. Here I take an example. From a list of employee, find name of employee older than 30, sorted by name in uppercase and collect into a list. So here we take a list of employee. Now here we will use some intermediate operations or some terminal operations. So here we use filter for find the employee who is older than 30, and map name into a uppercase, and dot sorted for sorting it by name, and we use collect. It is a terminal operation. Collector.toList, it will provide a list of employee as per above filter and map. Now we will know about parallel streams. Parallel streams automatically divide the data into chunks and process in parallel. However, we use them with caution. Side effect or non-thread safe operation may cause bugs. If you have a large data and want to leverage multi-core processor, then we can use parallel streams. Below are the sample codes you can check. Now we will see characteristics of streams. Once consumed, it cannot be reused. Laziness, intermediate operations wait until terminal operations. Non-interfering, do not modify the source. Stateless and stateful. Stateless operations are filter or map. Stateful, sorted and distinct. It can be infinite but need to be handled with terminal operations carefully. Now we will see the common use cases of streams. We use streams in data transformation, filtering data aggregation like sum or average, generating report, grouping and partitioning data, parallel batch processing. Now we will see the advanced example with grouping. Here is a group of employees by the age group. Here I added a check. If employee age is less than 30, then it will return young. Else if employee age is equal to or less than 40, then it will return mid, or else it will return senior. Now we will know how to implement a streams. For streams, you need to import Java util streams, get a stream from a collection with dot stream, chain intermediate operation, and finish with a terminal operation. Now we will see summary. Streams, same functional declarative data processing, source intermediate terminal, supports parallel execution, makes code more expressive. Mastering streams is essential for writing modern Java code.